Today I'll be talking about optical character recognition. So it's nothing but more of digital text. So we have been talking about digital text a lot in recent years. This is about me. Blended talk about um, my professional experience in data world. I have master's degree in data science, master's in computer science, and then close to 9 years of experience in information technology. Beyond the code, uh, so I have a year-old kid. So here is kind of thing that we both love llama, but he loves llama red pajama, and I love llama 3 from Meta. We have some demo for LlamaIndex and LlamaParse. That's related to OCR again, and that's newly introduced about 4 or 5 weeks ago. They launched those services. Um, Food enthusiastic, and I'm language lover. I can read, write, speak 5 languages. Um, so jumping to today's presentation, this is the agenda.
What 5 languages?
So my local language or my mother tongue is, so 3 of them are Indian languages. One is Sanskrit, you might have heard, it's the oldest language, then English and Japanese. This is the agenda that I will be covering today. I'm starting from basic of optical character recognition. It might get too technical in between. Feel free to interrupt me in between if you feel that's too technical. We can talk about strawberry cheesecake recipe if Glenn allows. But so uh, we'll be introducing OCR, little bit of in technical detail what exactly OCR does and why is that technology getting more attention. Then some part of image processing, because that is again important when it comes to OCR. Some components of OCR and LLMs in OCR. Now we all know everything is LLM, large language model. We have presence of large language model everywhere. So I'll be introducing a little part of that in terms of OCR. Okay, what is OCR? It's the technology that converts images into text. So we have a lot of scanned images, digital photos, or whatever images, and there are some text hidden in it. So extracting that text is optical character recognition. Okay, so there are two main parts when we are looking at the image. One is text detection and text extraction. As you can see in the image, for a human eye, we know there are 4 characters. It's a stop sign. For STOP, there are 4 characters. But out of whole image, there is a region where that particular or the word is located. So locating that word or locating character that comes in uh, text uh, text detection and extracting those characters like STOP that comes in text extraction. So these are two concepts related to text related to OCR. So text extraction, it's the process of converting uh, now we have located the area and we want to extract the text or the character out of it. As you can see in the image, it's a binary image, or you can look at it as 2 by 2 metric of zeros and ones. So the character A is represented all by ones. So if we just concentrate on ones there, it forms a pattern, and that's for human eye we call it as A. But then how do we make machine to understand? So there are three methods. One is template matching. Next is feature extraction, and the most common method is deep learning. So template matching is more like we know there are two slanting lines and then horizontal lines, then that's a template, that's A. Next is feature extraction, meaning in terms of images, we need to get the intensity of the pixels where we are seeing once. And then deep learning is the most common method. Most of the OCR engines are working on these algorithms, RNN, and CNN. Those are deep learning methods, recurrent neural network and convolutional neural network. So these are two methods that are most common. Um, Next is, how does OCR work? So there are main four steps for OCR. The first one is image processing. So when we have image coming in, in most of the cases, we cannot use image directly. Either we have to crop it, the resolution is not perfect, or it's not very clear image. So we need some type of image processing in there. Um, then we have character segmentation, character recognition, and post process of it. So I have a figure that, so as you can see here, there's a word KNOW. So for again human eye, we know that word is no, but as first step is to localize where the text or the characters are located. The next is we need to differentiate each character, because then the algorithm is going to detect each character separately. So algorithm will not know the whole word. It is going to work at character level. So in the second figure, we see there are four words or characters. Those are being separated. And once the character is separated, then we use trained OCR model or a deep learning model to detect those characters, and then those characters will form a word. Um, Now, what are benefits? Definitely reduce cost. We don't have to enter the data looking at the pictures manually. Um, Increase efficiency, and then improve accuracy, because we do have good machine learning models as an OCR engine. Um, okay, so here are the applications. The first application or the most common is in data entry. So for example, if you look at our tax forms or driver's license, we do have scanned copies of it. But instead of a person entering it manually with having a lot of mistakes and spelling mistakes or taking a lot of time, we do have technology like OCR that is going to detect the text, and we are going to have the information extracted from the document or the image. Um, the last so the last line says accessibility tools for visually impaired users. So we know features like Adobe or a Microsoft Word, they do have options where they can go through document and they can read it line by line for visually impaired users. But how they are going to read when it is just an image? So they definitely need the text to be extracted from the image, and that's a major use case of OCR.
Question.
Good.
I figured I would take the invitation to have the conversation. When you mentioned accuracy, I was surprised because typically you hear. I would think the worry that a layperson or a business person without the technical knowledge would say, well, what if it gets it wrong? We need a person to verify this. So, in replacing traditional means of entry, what are the industry, like perceptions of this as a viable technology, as well as like, how might it handle variance in different people's shorthand or weird ways of writing, punctuating, things like that.
Yes. One part is handwriting recognition. So before going to extract text, first we need to recognize handwriting. So handwriting recognition is a type of OCR, but then we need to have another trained model for handwriting recognition. Okay, now let's say I'm just giving you one example of OCR engine or handwriting recognition from Microsoft. That's they are having as a form recognizer, or there's a service, I don't remember the name, but they do have service for handwriting recognition. And so each OCR service, they give you a score of scores in terms of number, that is called as confidence score. So when the score is high, let's say 95%, so the model is 95% confident that this is correct recognition. And when the score is very low, so usually for open source OCR, we take about 70% of confidence score as a margin. If it is below 70, we don't have much confidence about that particular prediction. So depending on that confidence score, we go ahead for the accuracy. And then, so next part is, so when you say when a person coming in, and isn't that accuracy greater? So it is greater only when one person is coming, but when you have a company where n number of data or data entry operators are working, then again there is no quality of input. So I hope that answers your question. Okay, yeah, go ahead.
How have you seen AI help out with this? Because nowadays, just from my personal experience with it, I've seen where you can read in text to a document and AI can scan that document and fill in the words that are missing or contextually correct the words that are wrong. So have you seen that really come into play in the recent years?
Yes, definitely. So I've been working on OCR technology since 2020. We have worked, so I mentioned this year because that year is before this era of LLM. I'm calling it era because it's actually a time travel. And if I talk about how did we develop like all these before coming AI in picture, it literally, I had 7,000 lines of code, and today we literally have 450 lines of code, like for same project. That's a product that we have deployed on government website, where we were trying to extract ingredients and nutrient contents from a product label. So where AI is coming in picture, I mentioned about post-processing of the data. So if the image is not clear, I know there is a character missing or something is missing, where right now AI is playing a big role. But prior to this, we used to write spell checks. We used to write, I've written a code to literally match the strings to make sure that spelling is correct. And that algorithm itself, because the computational cost of computation was so high, it took 2 to 3 minutes just to run through that algorithm. But now with any of the LLM, you go with Meta's LLM, Llama 3, you go for OpenAI, and literally every large language model, you are having new model a day, I would say literally a day. And so it is helping a lot in post-processing part. That's major part. And definitely they also have improved or fine-tuned their model in terms of character recognition. So OCR is definitely have improved since 2020.
I have a question.
Yeah.
You make it sound like there's a lot of different options to bring to bear for a given string of text to recognize the characters in it. Are the strengths and weaknesses such that it's useful to use the ensembling methods to have, if you don't get that 70% threshold confidence with this algorithm, if you switch to another one and see if that's going to get beyond the threshold, if that doesn't work, you switch to another one?
Okay, good point. So we have developed this method. So if you're looking for OCR engines, there are open source OCR engines, and then we have paid from three big players, Amazon, Microsoft, and Google. So what you're talking about ensembling method, PyTesseract is most common, then PyNewPDF is the second one. So we have developed ensembling method using three OCR engines, but the computation cost is a lot because it is taking a lot of time. It is in the end beyond the scene. It is a deep learning model. It's taking a lot of time to execute one page. So you're talking about character level and word level. So imagine the complexity. So, but we have done that. Yeah, taking three of them and then try to at least predict the word. But it was not, the prediction was not machine learning trained. It was purely based on um, string sequence, and there's a library, NLTK library, that will give you spelling or spell check. So we used to that, but it did not help much.
You said NLTK for spell checking?
Yeah.
Yeah.
Yeah, again, that's spell checking. NLTK was again back in 2020. Okay, so this is just a screenshot from Google's Vision API. So I'm mentioning all these OCR engines from the cloud owners, I would say Google, Amazon, and Microsoft. They do have their different strengths and weaknesses. Again, they are launching new, I would say, facilities in their API day by day. So Google's Vision API is ready on their website, so we can just go ahead and upload the image, and we'll get the output. So on the okay, my cursor is not there. So the first image is the one that I've uploaded, and these are the outputs. So this is JSON output, and so the output is given in terms of page level, line level, then we have word level and character level. These are coordinates. I'm going to talk about that in later slides, but the output just looks like this from Google's API. Okay, then what are the advantages of cloud-based service when we have so many good open source technologies? Definitely scalability, accuracy, and accessibility. So we talked about, since it is deep learning model, in terms of computation, it is heavy or costly. So accuracy wise, before OpenAI came in the game, Google was doing better. And at that time, Amazon had, back in 2020, Amazon had one model. They were able to detect the table and the table cells correctly. But now with OpenAI, we do have much more advanced services with OpenAI and other um, I think Microsoft also, they have good OCR. now. Okay, so I think I'll run all the demos at the end.
Okay,
Because
yeah, that sounds fun. And also with the questions, which we would encourage, it may lengthen your presentation. So we'll see.
Okay. Okay, so when we talk about OCR, image processing is an integral part of it because in the end we are dealing with images. So I've been actually I wanted to show the demo, but that's okay. That's okay. I'll do it at the end. So for image processing, OpenCV is most common used library. Why do we use that library? It's very easy to use. Apart from that, it gives additional functionalities like we can read, write images. So in image process or image manipulation, most of the time we definitely need to filter the image, resize the image, or some extraction of features like edges, corners, or if you want to locate the word, what are the bounding box of that. So all these functionalities are easy and good provided by OpenCV library. So that's some just introduction of image processing because we are going to need it when we are going to look at the OpenCV OCR demo. Then we have, okay. So I did talk about pre-processing. So what all options are there for pre-processing? One is image enhancement, binarization, and skew correction. So some of the time I have seen, even if we think that image is, uh, it is not tilted, but it is tilted either by 1 degree or 2 degree. Even that 1 degree or 2 degree can affect our OCR engine or deep learning model, and that will again reduce or decrease the performance in terms of accuracy. So correcting skew is important, and image enhancement we have seen in most of the images, the edges are not darker or so I guess image enhancement, then feature extraction and character segmentation we have seen. How do we separate each character? So this library will help us with that. Yeah, go ahead.
In terms of binarization, converting the image to black and white, is that just like simply converting the image to black and white, or are you like specifically trying to target the text?
In some cases, yes. So let's imagine you have a document with some image on it, and you're trying to just focus on text part of it. So if you imagine if you convert it into black and white, and now image is going to have all the pixel located very closely, unlike characters. So that logic is applicable in that case. Hence, gray image is the first part of it. Okay. I did talk about bounding boxes. We have seen that in the output of Google's image. So this is the input image, and we see how this paragraph or this section is clubbed together, each word and then each character. So when we get output from any OCR engine, we are going to get bounding box for each character or word level depending on OCR engine. So why do we need bounding box? So imagine this is whole paper, and I want to locate this word wedding. I need some coordinate in terms of XY plane geometry. Just imagine this as a quadrant starting from there 0 0, and I will need some coordinate to get to this word or this W. So those are bounding boxes. So the libraries that I mentioned earlier, they give you bounding box directly, and you can use them to plot. I have a demo showing that. Okay, I guess I'll just jump through this. Major challenges here, complex layout. So when we are talking about OCR or any document, the document is not going to be a simple document having text. They are going to have some complex figures. This is called as two-column layout. This was very challenging again back in 2020 to figure out this is one column and this is second column, because OCR engine won't know this is not a complete sentence. We need to write additional code in terms of that. But right now we do have everything ready made. Yeah, so considering different format or different components of document, layout analysis again is integral part, because as I mentioned earlier, I need to focus on textual part of it. So I should be able to at least differentiate what are words, what are image, where are they located in terms of bounding boxes, where are figures. So layout analysis is again one part of OCR. Again, why it is important, because we need to know um, where each component is located. That's the main purpose of layout. And we do have libraries right now. They will help us understanding the layout. So there are again common techniques for layout analysis, out of which again machine learning and deep learning is commonly used in most of the machine learning algorithms. Okay, so skipping to use cases. So this is one of the use cases we have worked on. We did not work on W4 form, but some other government forms. So let's, so I called it as structured because this is W4 form, and if you go across United States, this form is going to stay same. If we plot this form on a paper, we are going to know where the first name or whatever social number or the address is going to be. So those bounding boxes are going to help me understand where my first name is located, where is last name or PO box number or the address is located. So depending on that bounding box information, we can definitely extract first name, last name from the forms like W4. And these forms are structured because we know the structure is not going to change. So these forms are easy to handle because we know what is coming in. But when we have shipping labels or labels from different countries, labels from, I would say, different languages, it is difficult because there is no uniform pattern, and extracting information from this is difficult because in some cases, importer's name could be there, in some cases it could be here, country will be in different location. So that's again challenging part with unstructured data, unstructured labels or unstructured images.
Question on that one.
Yeah,
How well do these readers work for deciphering like a currency label that's in a foreign currency, for example?
currency? Not very good. No.
Okay.
Open source model, not very good, but if we go for paid service from these three big players,
Yeah,
they are
okay.
good. Out of that, we experience Azure is good. Microsoft's solution is good. Yeah.
Right.
Okay. So can we develop OCR from scratch, or if we want to have our own OCR engine? Yes, that's possible. We tried, the accuracy was close to 55% when the market players, they are having close to 89%. So that big difference, because we tried it with open source data sources. They definitely do have labeled data already available. You can use CNN model or fine tune it, but definitely not worth the hassle. Um, okay, now coming to yeah, go
So
ahead.
question then, what was the motivation to try to build it?
So
I mean, sure.
my motivation was my local language. It has different script, so I wanted to try that
Yeah.
if handwritten papers can be translated. So that was
Okay, so specifically the challenge of handwriting.
Yeah.
And trying to build something to interpret hand.
Yeah.
Yeah, okay,
And then-
I get it.
Yeah. So my
But
mother
it's-
tongue is not very common. So that was
Even more
another.
so, it's handwriting in Sanskrit or something
Yeah.
similar. So-
Yeah, yeah,
So,
yeah, I get it, okay.
To that extent, would like a deep learning type methodology at your character recognition stage allow you to kind of build out an OCR engine that would have functionality across multiple languages to be able to do the kind of thing that you're talking about, as well as English, as well as German, and things like that?
Yes, it is possible. The only catch here is you need very good quality labeled data, and that is what the data world is struggling. We don't have good labeled data for that. So
When you say label data, you're referring to the structure like we just looked at.
yeah, so when I have image that's handwritten A, so it should have label like English A or capital A in there. So
Is part of the issue you're talking about here, that there's not a lot of digital like text in that particular hometown language
yeah,
that exists on the internet.
so
Might not even be a lot of character sets for that language.
character set is available, but labeled data is not available. So when I'm writing some character that tends to English M or A, so that mapping needs to happen so that machine can learn, and then they can help us. Okay. Document extraction using LLM. So this is again whole different game that what we saw earlier. What we saw earlier was pure OCR engine, and then we are trying to extract text and then do some post processing. So here I'm going to talk about LlamaParse and LlamaIndex. So this Llama has nothing to do with Meta's Llama. We don't know, but why that name Llama came here. But yeah, so they launched Llama Cloud and LlamaParse LlamaIndex 1.5 months ago. They are claiming that they are way great. They have so table parsing was a major challenge up until now. Earlier I mentioned AWS was doing great, but then Llama folks came in, and then they are claiming that they do have very high accuracy in table parsing. I myself have checked just 20 documents, not more than that, but they are really, really good. We don't know what exactly they are using because everything is not revealed, but they are really, really good. And we can connect to any LLM, be it local. So if we don't want to go for OpenAI or anything, we can definitely build it locally. I myself have built it locally using Llama 3. So LlamaParse is more their OCR service. And then we have LlamaParse feature. So the first one is table extraction. They are claiming they have very good table extraction. So table extraction was always a challenge because we might have merged cells, we might have a figure inside table, and that was very complex when it came in terms of understanding the document.
My problem was always that tables and documents had maybe single entries in a few cells, and then the third one maybe had line breaks or multiple entries
Exactly.
in it that was still the same cell.
Yeah. So
Interesting.
LlamaParse is doing really great. I just have tested 10 complex examples of table, but they are, up until now, I was fan of AWS extraction. Yeah,
So you're saying that they only released like what, a month ago, you said?
1.5 months, yeah.
So 1.5 months ago, and you're telling me that they can extract like Excel? Like, and you can put these things into like,
Yes, they have 10 supported file types.
wow, that's pretty crazy.
Yeah.
Uh-huh.
So right now it is free up until 1,000 calls. So that's what I was using. But definitely they are going to charge much more. But then recently on Google's website, they do have 2 more models. They are not production ready, but as a developer, you can use them. Document vision, something. So uh, Google has been always great in translation in terms of more number of language support and good accuracy. So now they have launched a service which I came to know this morning. They launched a service where you don't have to go for different OCR engine and then translation engine. Nothing. They all have just one service. You just insert any image, any document, but that is not production ready yet. Just available for developers.
So have you seen the cost of the big major players go down?
Might.
So they're just gonna push everybody out of it to
Yeah.
the point where they're not gonna
Yeah.
do
So
this.
we are experiencing some. I mean, the cost is not going down directly,
Right.
but they are upfront offering you X number of credit.
Well, for the accuracy, the cost is gonna be a no-brainer.
Yeah. But they are at least for our purpose, because we are working with government projects. So major deal with government is that they don't allow all of the services. So this is definitely not allowed. So they just have allowed Google, some services of Microsoft and this, that. So based on that, now we have, I mean, there are most of the models or most of the things are already deployed on their cloud, and they are already using Google's and other things. So if they need to be in the game, they need to get it FedRAMP approved. I mean, that's a whole long process, but it's really, yeah. This
Before you
is,
continue, could I ask you a question?
Yep.
If you're going to try to use optical image recognition on, say, a page of a PDF,
Mhm.
and you're going to rely upon an OCR model that's cloud hosted,
Mhm.
on average, how many API calls are you going to have to make to get through one page?
oh,
Is it
so
hundreds or is it just 2 or 3?
no, so for if you are using cloud, one API call can handle multi-page PDF.
Okay.
So if you have 10-page PDF, you can just send it to one call, but the return response time is little more than compared to one page.
Gotcha.
But multi-page PDF support is available in all APIs.
When you say response times, what are you talking? Seconds? 10, 15, maybe?
Yes, 10 to 15 seconds, yeah.
Negligible.
And then LlamaIndex is indexing the documents. So up until now, we have very good indexing service from Amazon. It's called Kibana. That's the interface that you are using. But LlamaIndex is more like you have bunch of documents, you extracted everything, and now that engine is indexing everything so that you can search, you can ask question, you can do anything what you are doing currently with ChatGPT. Basically any LLM model. So LlamaIndex is helping to index the document, indexing all the documents or creating a vector database or knowledge database such that it is easy to extract. And so the model itself can understand the context. So we can connect LLM easily.
How quick is that?
LlamaIndex, so I personally have tried with just one document with 20 page. So performance.
When were you able to start searching?
So you mean the indexing process? Yeah,
how-
it did not take a lot of time. It just took close to 3 to 4 minutes.
And then you're able to
Yes.
query
Yes.
the data.
Yes.
So, trying to keep track of.
Yeah.
It'd be difficult for a human to do.
Yes. And then, so use cases for LlamaIndex again, question answering chatbot. So let's say you have set of documents related to your company, or you have proposals of your company. You put everything using it can be a image document or the other documents. You just dump everything using LlamaParse, LlamaIndex. And now you have your knowledge base ready, and you can ask any question. Oh, I remember this proposal. Can you tell me what was the revenue or similar thing? Okay, so we cannot use LlamaParse or LlamaIndex without API key. So this is the Llama Cloud API interface where you just have to go in and create API. That's free for now. So just conclusion, we have gone through text detection, extraction, bounding box, benefits of OCR, and then LlamaParse and LlamaIndex. I'm going to jump to demo. Okay. So this is first. This was supposed to be my first demo, but this is simple OCR. Here I've used PyTesseract as the engine. So I'm going to share these notebooks with Glenn so that he can share and you guys can access it. It's easy runnable. I have input images as well in the whole folder. So some installation I'm not going to go in detail in the code, but if you have anything in there, just stop me in between and yeah. So that's so this is the image, input image, and we do have translated text in here. I hope you all can see once. Okay, so this is input image, and we have translated text. This is from PyTesseract. Translated text is good, but you can see here instead of bullet, I mean, it was a little confusing for Tesseract to see like what exactly it was. It literally gave 3 different outputs. But that is not the case with Google or other services with high accuracy. The second part is part of the demo is bounding box. We did talk about how we are going to localize particular text in the whole image. And I did mention that we are going to get X and Y coordinates. Sorry. So these are the coordinates that, oh, sorry, let me the image. Let me show the image first. Okay. So this is some car wash image, and out of whole image, we just know there is text that is located here. So what OpenCV helped me, so I plotted this green box using OpenCV because I knew from the library that these are the bounding boxes. So I know the location where it is, where the text was located, and I just plotted it. So that's more working like at pixel level, and you are trying to literally find out each edge of that characters.
Excuse me, showing the box in green is just for
Yeah, just for
show.
demo.
It's
Yeah,
just to show
yeah,
what's
yeah. And
happening.
then that's I have done using OpenCV.
So to clarify, you dictated the vertices for the box.
Yes. Yes. And I did not get those vertices on my own. I got it from OCR engine.
So the model found it itself?
Yes,
Okay.
model found it, and then I used it just for like demo purpose to show in terms of image processing. So we did talk about layout. So layout parser is again open source library. It was released by Meta or Facebook back then. It was released in 2020. So they had this algorithm coming in picture where you can locate the face of whole image, and then you can just tag a person. So this model is dependent on that. Okay, now this is input image, and here you can see the bounding boxes. It did recognize the layout, so it did know okay why. So this is a paragraph, hence everything is clubbed together. So identifying paragraph is a part of layout parser or layout analysis that's being done here. Next thing is this is heading. Then we have image. So this is very simple document, but the open source model was able to guess perfectly where particular image is located or the bounding box of that image, and the output was again given in terms of x and y coordinates. So that was one demo, and for yeah. Oh, okay, I'm 4 minutes over time. Just with LlamaParse and LlamaIndex. So this is comic, a page from comic, and this is from their again website. But if you look at this comic, it is difficult for a machine to understand where this particular sentence is getting over, and this is not a newspaper, or then something is not continuation of one sentence. Indeed, it's a different layout. So the open source model or the even Amazon's model could not guess like the sequence, because sequence is important. Other than that, there is no meaning of comment. So this was the original output with no sequence, like a newspaper distributor. Do I have wrong map? But this is from LlamaParse, and the sequence is what they are claiming, and layout understanding it's correct. So layout understanding is the table parsing was major problem. That's what they are handling. And again, just
Is that doing translation of the
yes,
Japanese characters?
yes,
Sure
yes,
is.
yes, yes, yes,
Okay, so where
So-
it says distributor, that's a translation
yes,
of the sign on the building.
yes.
Fantastic.
And then I think Glenn, you don't, you will not like this, because we have derivative on the as a question, and everything is being translated. So I've written a prompt here. That's again LLM part of it, but so the whole calculation and the uh, let so it is being translated in latex, and so that's where it is literally guessing each and every character of mathematics. So if we run it by, so after this, if we run it by open AI's model, you have the answer ready. So Glenn has been teaching mathematics.
For a couple of years.
Yeah.
Glad they have AI. Like, you can give them the problem and it shows the work. So then they're like,
got it.
But chances are it's the wrong answer for 2
Well,
+ 2.
In her defense, Wolfram Alpha's been doing that for decades, so.
Actually,
And
it's funny, my daughter just graduated from Bama. They were encouraged to use AI,
Yeah.
mainly to help them through it. So it wasn't so much, I don't care how you get the answer. This gives you a start. Tell us from that start, you know, how that goes through and prove it basically, because everyone knows AI will gladly tell you it's right, even though it's blatantly wrong. If you try to tell it, no, you're not, it'll double down.
For now, you gotta wait a couple of years.
Yeah. It adamantly hallucinates.
Indeed.
Not
So, but I thought that was very interesting that they were encouraging her to actually use the AI to go through to, you know, not so much to do the work for them, but to make them think about how is it that you're going to use this down the road. The one thing, I was going to wait until later, but since I already talked, why not? Earlier you said something about using a large number of images to train a model. Know someone else who's doing his PhD in organizational psychology. And I was surprised for them to train their model. They only did about 1,500. And that was it. I fully expected they would have used a lot more, but they just used that. And they've got a model that's pretty darn tight, which kind of surprised me.
Patterns are very prevalent in the world. People relate to patterns. AI can figure out patterns way quicker than a person can. So that's why when you teach your child, you establish these patterns. Well, imagine teaching a child that can do what a kid can do in a year in 2 minutes. It's dangerous.
But still a child.
Intriguing. And yes, I don't want my child to throw a temper tantrum and have access to the nuclear global launch codes. Sorry,
You teach your
kid.
child to turn off the lights though.
Yeah, that's what I'm saying. It's very simple.
I think that's all from my side. Any questions?
Are there further questions?
Yeah, I had another one. So it sounds like you do a fair amount of work in the sector where you're serving government entities. Do you see where this is going, where the rubber hits the road of the market demand for optical character recognition? With we are in the age of LLMs, as you point out, but there's all these organizations. I work in the public sector myself, so I understand how concerned government entities can be about data leakage. And so there's this big demand for, we have all this information, let's say it's 100 years of legal case history, and we want to get information out of it so we can get it into our LLM so that we can ask it questions. And that's where it sounds like the optical character recognition comes into play, is being able to efficiently feed it into such a model and hopefully store it locally so that you can ask it questions yourself. Is that where you think everything is going?
Yes, and I would think local models are better in terms of security. So for OpenAI, every time you have to hit the API. So there is definitely no one knows about the security there. So running model locally, I'm not sure if you have tried that. I did. That's Llama 3 I was running using Ollama locally. So yeah, feel free to connect. I was just trying to experiment something.
But isn't that a very specific use case though? Like you said, you're reading in those legal documents to kind of get that can be very secure. But at the end of the day, if you're trying to figure out what's the new, shirt that the entire United States is buying, you're never going to be able to establish that data set. So I could see, your point. But again, isn't the open source part of it going to lead the way in such a fundamental way that it's going to unless you have a specific use case like that, it's not gonna promote anyone to do anything because they're not, it's like going against Mike Tyson. Why would you try to fight him unless you had a very specific use case? So that's where it's interesting to see, because like you were saying, those other things are out there, but yeah, as you've seen within them, they don't hold a candle to what these people are doing daily, weekly. I'm just curious to see where that's going to go. And like you said, there's 3 major players. Is there ever going to be a 4th major player or a 5th major player? Nobody knows. Seems like Amazon, Google, and Microsoft are.
Yeah, but so right now Amazon is lacking in LLMs. They don't have. They do definitely support different LLMs, but they don't have anything of their own. They declare that they are working on something. Definitely, they need to upgrade themselves, but we don't have.
So already Microsoft and Google are pushing Amazon.
We can say, yeah, we can say that.
Or pushing Amazon to just toss money at the open source so they can, I mean, that's how all that crap goes.
Suggestion. That's crazy.
I have a question.
Yeah.
I think you made, I don't know if it words your mouth, but I think you made a comment like, when you first started talking about LlamaParse, that you said something like, you don't know what's behind it or causing it to be so accurate. Does that concern you at all? Or even like your employer?
Not really. It's going to be more fine-tuned model, but they are not going to release their fine-tuned data set the way others release it. So I think it's just more fine-tuned model with good data.
Okay.
Good.
I thought you said too, the Llama you can run it locally.
Yeah.
So you can have it in a closed environment. Whereas with Google and Microsoft, you can't download Google and run it from your PC because you have to use their database.
Yeah, you have
But
to
with Llama, you can do it locally, read in the legal documents, and then it's completely shut off.
Okay.
So that's why that has a very interesting take.
So we are trying open source more because you can do it locally. But then you need to have really good laptop.
Well, we're using the government. They have lots of computers that don't come close to anybody's. So you can.
And they've got a lot that the laptops run circles around as well.
Let's thank Revati one more time.
Thank you.